Time for the hard one. So as we're taking a look at example 4, note that I have a binomial in the numerator and a binomial in the denominator. So the issue is still this root 2 right here. We are not allowed to have a square root of 2 in the denominator, so the whole reason we're going through this process is to get rid of that root 2. So first we must identify the conjugate. Well, 5 plus the square root of 2 is the original denominator, so 5 minus the square root of 2 is going to be our conjugate. So multiplying this by 1 will look like, so let's do green. 5 minus root 2 over 5 minus root 2. Again, step 2, we don't usually write this part out, but it is the reason we're allowed to do step 3. 5 minus root 2 over 5 minus root 2 is equivalent to 1. Anything divided by itself is just 1. So the real meat of this example is step 4. Notice that in the numerator we have a binomial times a binomial, so that's a FOIL problem. In the past 3 examples, we only had to distribute in the numerator. In the denominator, that's a FOIL problem, but it's kind of the nice FOIL problem. We expect the insides and the outsides to cancel. We cannot make that expectation for the numerator. The numerator might have terms that cancel, but it might not. We're allowed to have radicals in the numerator. It's the denominator where we need that cancellation to occur. So let's go ahead and kick this off. In the numerator, first times first, add a little bit of color in here. We're doing this 3 times 5, so that's my first 2 terms. That's going to give us a 15. After that, it's our outside terms. First part of the 3 times the negative square root of 2. That's going to be a negative 3 root 2. Then we jump into our inside terms. Negative root 2 and 5. That is a negative 5 root 2. And finally, the last terms, negative root 2 and negative root 2. Now, a negative times a negative is positive. Root 2 times root 2 is a root 4, but the square root of 4 is just 2. So there is some simplifying we can do in the numerator. There are some like terms to combine. Go ahead and save that for the next step so we can clean up everything all together. Moving over to the denominator. Use the same color scheme we've looked at for the previous 3 examples. Take a look at these first 2 terms. 5 times 5 will be 25. We're expecting the insides and the outsides to cancel, so we'll do those in red. 5 times the negative square root of 2 is negative 5 root 2. Jumping out of the inside terms, root 2 times 5. That's a positive 5 root 2, so those will cancel the way we want them to. And then we have our last terms, root 2 times negative root 2. Positive times the negative is a negative. 2 times 2 is 4. The square root of 4 is 2. So that all comes together to be a negative 2. So let's clean this mess up. These terms did cancel the way we expect them to. In the numerator, we get some like terms. That's new. We have not seen like terms in the numerator yet. 15 plus 2, that's going to be 17. Again, that 17 coming from combining those 2 like terms highlighted in yellow. We also have like radicals. Negative 3 root 2 and a negative 5 root 2. Negative 3 and a negative 5 combine to make a negative 8. And then in the denominator, the insides and outsides cancel, so we're left with a 25 minus 2. And 25 minus 2 is 23. So step 5, we're always looking to see if anything cancels. In this case, we don't get anything nice. 17 is a prime number, so the only thing you could factor out of that is 1 or 17. And 17 is not a factor of 23 or 8, so really nothing else that we can do here. This is complete.